vector, it's a segment of a straight line that starts in one point towards another. It has a magnitude and direction. The magnitude is the units in which it is measured, and the direction is the angle between the vector and an horizontal line. We have the 2D vectors that are divided into two, the algebraic vectors that has coordinates in both points, and the geometric vectors that are just point A and point B and express a continuous motion or action. And also we have the 3D vectors that it's a continuous action or motion in a 3D space and has three axes, the X, Y, and Z axis. In order to calculate the magnitude of a vector, we need to apply Pythagorean theorem or a variation of it, and to get the direction of a vector we need to apply the tangent to the -1 of the y expression divided into the x expression of the vector.
Now I'm going to talk about the Coulomb's law. And the Coulomb's law is a physical law stating the force between two charges and is proportional to the amount of charge on both charges and inversely proportional to the square of the distance between them. The law is also known as Coulomb's inverse square law, and the formula for Coulomb is used to express the force through which stationary charged particles attract or repel on another. The force is attractive if the charges attract to each other, to have opposite sides, and also it had to be repulsive, and if the charges have like signs like positive and negative, it's going to be repulsive, and it's going to have.
The problem that it's presented, it's about a system of charges. We have the 3D model of it. The pink ones represent the negative charges and the blue ones positive charges. As you can see, we have a prism, and in the center we have one charge. Our role here is that we need to calculate the resultant force of the interaction of all the forces against each other. The pink ones will attract the other forces, and the blue ones will repel the other forces. With the use of the Pythagorean theorem, the Unitarian vectors, and other tools that we had on class, we're going to calculate this resultant force.
We have the dimensions, the charges, the 1 to 9. But as we remember of that the problem said that the number 9 is going to be the center, okay? So then with this formula here, with this formula we can find the length of the vectors, okay? And then with the Coulomb's law, with all the charges we have to multiply to the charge number 9, as I will already say the number 9 is the center, so we have to multiply one single charge for the number 9. And then here we continue to the number 8. Okay, we have to make the same procedure, and then we have to obtain the angles of all the forces vectors, and we have to find also the complements of every single force. And at the end here, and I'm sorry, so for you can understand, here in this place is the result of the Coulomb's law, and here is the result of the angles, and we have to make the results of the Coulomb's law, cos of cosine, and the angle, and this is going to be our results of every single force. And it's the same procedure until the number 8, and at the end here we have to do the addition of forces, and we're going to have our results. So